Hello everyone, I am Dr. Muralidharan J, Associate Professor, Department of Electronics and Communication Engineering, KPR Institute of Engineering and Technology, Coimbatore. Today we are going to discuss about the topic digital communication. Generally in digital communication, the transmission of information is in the digital form. The below figure shows the model of a digital communication system. First, it starts with discrete information source, then source encoder, then it will move on to channel encoder, then modulator. The output of the modulator is connected to the electrical communication channel, where it will also get a noise from the outside environment. The output of the electrical communication channel is connected to the demodulator, then it is connected to channel decoder, then source decoder and the destination. Let us consider the discrete information source. In case of digital communication, the information source produces a message signal that does not continuously varying with time. Rather, the message signal is discontinuous with respect to time. The output of discrete information sources are such as teletype or the numerical output of any computer consist of a sequence of discrete symbols or letters. An analog information source may be transformed into a discrete information source through processing of sampling and quantization. Let's move on to the source encoder and decoder block. The symbols which is produced from the information source is given to the source encoder. These symbols cannot be transmitted directly. Therefore, they are first converted into digital form, example binary sequence like ones and zeros by the source encoder. Each binary 1 and 0 is known as a bit. The group of bits is called as a code word. The source encoder assigns code words to the symbols. For each distinct symbols, there is a unique code word. The code word length can be 4, 8, 16, or 32 bits long. As the number of bits are increasing in each code word, the symbols that may representing also get increased. For example, if we consider 8 bits would have 2 power 8, that is 256 distinct code words. This means that 8 bits may be used to represent 256 symbols, and similarly 16 bits may represent 2 power 60, that is 65,536 symbols, and so on. Some typical source encoders are pulse code modulators, delta modulators, and vector quantizers, EXA. Let's move to the block channel. After converting the message or the information signal in the form of binary sequence by the source encoder will be transmitted through the channel. The communication channel will add the noises as well as interferences to the signal which is transmitted. Hence, errors are introduced in the binary sequence received at the receiver. Therefore, the errors are introduced in the symbols generated from these binary code words. So, the channel coding is done to avoid these type of errors. In fact, the channel encoder adds some redundant bits in the input sequence. So the redundant bits are always added with some properly defined logic. As an example, let us consider the code word from the source encoder to make it a 4 bits long. This fourth bit was added in such a manner that the number of ones in the encoded word remains even. That is even parity. Let's move on with the digital modulators and demodulators. If the modulating signal is digital, which is in the form of binary code words, then the digital modulation techniques were involved. The carrier signal used by digital modulators is always a continuous sinusoidal wave with high frequencies. In fact, the digital modulators map the input binary sequence of ones and zeros to the analog signal waveform. For example, if one bit at a time is transmitted, then the digital modulator signal is S1 of t to transmit binary 0 and S2 of t to transmit binary 1. The signal S1 of t has a low frequency when compared to the signal S2 of t. Hence, even though the modulator signal seems to be continuous, the modulation process isn't discrete. This means that a signal carrier is converted into two waveforms, namely S1 of t and S2 of t, because of digital modulation. At the receiver end, the digital demodulator will convert the input modulated signal into sequence of binary bits. A digital modulation method must have the following important parameters: the bandwidth needed to transmit the signal, probability of symbol or bit error, synchronous or asynchronous method of detection, complexity of implementation. Next, we will move on with the communication channel. The connection between the transmitter and receiver is established through a communication channel. The communication channel can take place through wirelines, wireless, or optical fiber channels. The optical disc, magnetic tapes, disc are also considered to be a communication channel since they can also carry data through them. However, it may be noted that each and every communication channel has some problems. Let us see few issues of the communication channel. First, signal attenuation. The signal attenuation in the channel occurs due to the internal resistance of the channel and fading of the signal. Next is amplitude and phase distortion. The transmitter signal is distorted in amplitude and phase, which may be occurred due to nonlinear characteristics of the communication channel. Additive noise interference. The additive noise interference is produced due to the internal solid state devices and resistors, etc., which is used to implement a communication system. Next is multipath distortion. The multipath distortion occurs mostly in wireless communication channel. In fact, the signal coming from the different paths tends to interfere with each other. Now let's move on to the fundamental limitation of communication systems. In general, during the design of communication system, we may face several constraints or limitations. First, let us see what is noise limitation. The noise may be defined as an unwanted form of energy which tend to interfere with the transmission and reception of the desired signals of the communication system. The noise cannot be eliminated completely. However, the effect of noise on the desired signal can be minimized with the help of several techniques. Noise can be classified into two broad categories depending upon its sources. One is external noise, another one is internal noise. The external noise is the type of noise whose sources are external to the communication system. For example, the external noises are atmospheric noises, galactic noises, and industrial noises. Internal noise is a type of noise whose sources are internal to the communication system. The example of internal noises are thermal noise and short noise. These type of noises are inevitable in every communication system and forms a basic limitation of the transmission as well as with respect to reception of the signals. In fact, the noise limits our ability to identify the intended or desired message correctly and thus limits the information transmission. Typically, noise variations are measured in microvolts. If the signal variations are quite large in comparison, then the effect of noise is very small and may be ignored. In fact, in many practical communication systems, the effects of noise is generally unnoticeable. However, in long distance communication systems operating with a limited amount of signal power, the signal may be as small as noise or even smaller than noise. Thus, in such cases, the presence of noise severely limits the capability of the communication system. Next, we will discuss bandwidth limitation. In addition to noise, the bandwidth limitation is another major constraint in any of the communication system. The frequency range or band of frequencies needed for a particular transmission is called as bandwidth. This band of frequencies required for a particular transmission is called as channel. This band of frequencies or bandwidth for a particular transmission is always allocated by some regulatory agencies. This type of regulations is essential to avoid interference among the signals having same frequency. But for a given transmission, this allocated bandwidth may be sufficient to convey the entire information. The information theory states that the greater is the transmission bandwidth of a communication system, the more is the information that can be transmitted. Let us consider a simple example. Suppose one is listening to a music in an AM radio. The complete amount of information available to the human ear is contained in a frequency range up to 15 kHz. That is, the musical information can be extended up to a frequency of 15 kHz. However, in AM radio, the maximum modulating frequency is restricted to 5 kHz and hence the maximum bandwidth of AM transmission is going to be 10 kHz. If we calculate the bandwidth, which will be equal to twice the maximum modulating frequency, which will give you 2 into 5 kHz of 10 kHz. Therefore, an AM radio receiver cannot produce all the information contained in the music because will require a bandwidth of 30 kHz. On the other hand, the bandwidth allocation to the FM transmission, it is about 200 kHz. Thus, FM receiver can easily reproduce the transmitted information without any distortion. The FM system has a better fidelity when compared with the AM system. Also, it may be observed in common life that one prefers to listen to FM radio than AM radio. So, we can conclude that the bandwidth is a major fundamental limitation of the communication system. Now let's discuss the equipment limitation. The noise and bandwidth limitation dictate theoretically what can and cannot be achieved in terms of performance in the communication system. However, when we consider the theoretical limits, it may not be realized in a practical system due to equipment limitations. For example, theory might require a bandpass filter with a quality factor of 100 at a center frequency of 1 kHz. Such a filter cannot be realized in practice. Even if a filter with nearly identical characteristics is built, the cost may be higher. The equipment limitation is another major concern in any communication system. Now let's move on to the applications of electronic communications. The electronic communications has a wide range of application across various fields. Here are some notable examples. Let us consider the business communication. The electronic communication is extensively used in the business world for internal as well as external communication. Email, instant messaging, video conferencing, and collaborative platforms facilitate communication between employees, teams, and clients globally. When we consider the education, the e-learning platforms, video conferencing tools, and educational apps enable remote learning and access to educational resources from anywhere in the world. Students can able to attend the classes, collaborate on projects, and interact with teachers electronically. Let us see what is about healthcare. The electronic communication plays a vital role in healthcare for sharing patient information securely among healthcare providers, scheduling appointments, telemedicine consultation, and remote monitoring of patients' health conditions. When we consider social networking, the social media platform allows people to connect, share information, and communicate with each other across global instantly. They serve as a platform for entertainment, information dissemination, and social interactions. In government services, the electronic communication have various services such as e-governing portals, online tax filing, electronic voting, and public service announcement. These platforms enhance efficiency, accessibility, and transparency in governance. In the entertainment and media, the electronic communication platforms like streaming services, online gaming networks, and digital content distribution channels enable users to access entertainment content, connect with other users, and share experience in real time. In research and collaboration, the scientists, researchers, and academics use electronic communication for sharing research findings, collaborating on projects, participating in virtual conference, and accessing academic resources from different parts of the world. In finance, the electronic communication having a crucial in financial sectors for online banking, mobile payments, stock trading, and secure communication between financial institutions. It enables fast, convenient, and secure transaction globally. In transportation logistics, the electronic communication technologies such as GPS, telematics, and tracking systems are going to be integral to transportation logistics for route optimization, vehicle tracking, real-time monitoring of shipments, and communication between drivers and dispatchers. In emergency services, the electronic communication will be coordinating with the rescue operations, disseminating emergency alerts, and providing real-time updates during natural disasters, accidents, or other emergencies. Overall, the electronic communication revolutionized how people interact, work, learn, and conduct business in the modern world, fostering connectivity, collaboration, and efficiency across various domains.